Okay, and at the end of the Chapter 3 review, you've got question 18. You've got a sign that's being strung between two lengths of string. So if we were to draw the free body diagram, we would have this mass, and it has three forces acting on it. We have a weight force, we have a tensional force on the right, and we also have a tensional force on the left. So what I'm going to do is, knowing that this is an equilibrium, you would expect that the addition of all of these forces will be the same. So you'll end up with something like this, where the downward force is your weight force, this force here would be the rightward force, and this one here would be the left force. So what we've been given in this is a couple of angles. So we've got this angle here as 70 degrees, and we've also got, if I put a dotted line here, you've got this angle here as 35, which makes this one here 55, and this one here is 20. Now I'm going to draw my diagram a little bit bigger, so what I end up with at the end would look a bit like a weight force, force on the right, and a force on the left. And I know this angle here is 70 degrees, I know this angle here is 55 degrees, and I know this angle here is 55 degrees. Alright, so I'm just solving a non-right angled triangle, so I'm going to use the sine rule in this case, where we have, the generic term is A over sine A is going to be equal to B over sine B. So in this particular case, that would mean, so if I was to do, TR seems to be the easiest right now, because you notice it has the same angle on the other side of it as the weight force, so that would mean that I've got W over sine 55. So that divided by that is the same as this divided by this, so TR over sine 55. So from that we can say, well, then we should know then that TR right away is just going to be equal to the weight force, which is 12.5 times 9.8, which is 122.5 newtons, or I'll round to the even number, 122 newtons. And then to finish up, you've got now TL. Using the same method, TL is going to be equal to, again, W over sine 55. So it's TL divided by whatever, so in this case I'm going to multiply the other side by the sine of 70. And if I do that, I'll end up with 122.5 over sine 55 times sine 70, and you end up with 141 newtons. There we go.